In this video submitted to www.free-academy.com, the user is asking us to find the intervals under which this function f of x equals x to the third all multiplied by x squared plus 2x minus 3, where it is concave up and it is concave down. This is very interesting for us because the problem immediately gives us the second derivative and just wants to find the intervals of increasing and decreasing and find all the values of x where the inflection points occur. And beyond that, we don't need to calculate the y values of that, we just need to find the x values. So let's dive right in. We're going to have inflection points wherever the second derivative is equal to 0. Although I say that with a bit of a caveat because it can be equal to 0 but not necessarily equal to an inflection point. And we find that out by actually doing the interval test. But before we do any of that, we actually do need to calculate where this function is equal to 0. Now this has been paired off nicely for us already. We can take our x squared plus 2x minus 3 and factor this, and this should be equal to plus 3x minus 1, all equal to 0. And this should give us values of x equals 0, coming from the x third there, minus 3, and positive 1. So this is going to be our potential inflection points. Now we need to set up intervals to actually determine this for sure. We'll have an interval from negative infinity to negative 3. Then we'll go from negative 3 to 0, from 0 to 1, and from 1 to positive infinity. Now we need to pick a value in each one of these ranges to test in the equation. And depending on whether we get positive or negative outputs, we'll know whether it's increasing or decreasing. So we'll take negative 4 and put it in here. So f prime double prime of negative 4. So give us negative 4 to the third power. It's negative 4 squared plus 2 times negative 4 minus 3. And I'll just plug this all into my calculator here. 4 to the third power. This is negative 64 times 16 minus 8 minus 3. So this is equal to negative 64 times positive 5. And this is equal to negative 320. Although I didn't really need to calculate that, we just need the negative. So this is a negative. Now let's go back and let's put negative 1 into this equation. So f double prime of negative 1 is equal to negative 1 times 1 minus 2 minus 3. This is equal to negative 1 times negative 4, which is going to be equal to a positive. So we get that out. Now we need to do the same thing again, but we need to do it with positive 1/2. And we're going to have to do this for all the test values. So this is 1/8 times 1/4 plus 1 minus 3/2. 1.25 minus 1.5, all divided by 0.125. Well, this is going to be negative, this is positive, so that's equal to negative. And then we do this one last time using 2. This is going to be equal to 8 times 4 plus 4 minus 3. That's a positive times a negative, so that gives us a negative value there. Alright, so now we've done the test. We've gotten all our positives and negatives. Now wherever we change from a negative to a positive value, we have an inflection point. So our inflection points are -3 and 0. An inflection point does not occur at 1. We do have a critical value at 1, but we're going from a negative or concave down to concave down. Anyways, our negatives are concave down, our positives concave up, concave down, concave down. So we have inflection points, so we have concavity. Let's check this on our graphing calculator. And right here is -3. So remember, our inflection points are -3 and 0. We have concave down from here to 0, and we have concave up. Did I make a mistake? No, I did make a mistake. We have concave down from -3 all the way to 0. We have concave up from 0 or to -1 to 0. Then we have concave down from 0 to +1, concave down. We seem to change to concave up at some point too. Let me check this again. That was 8, 4 plus 4. This is a positive. Alright, that was my mistake. This is positive, so that's concave up. So that means our other critical point occurs at 1. So from -infinity to -3 we have concave down. From -3 to 0 we have concave up. From 0 to 1 we have concave down. And from 1 to +infinity we have concave up. And we have critical or inflection points occurring at 0, 1, and -3.